Lesson 1, Future Value and Length of Loans. So the first thing that we're going to do is create an amortization table. So when you're having a loan, you have a certain amount in your balance that you're owing, and then an amortization table helps you take regular payments and show how long it'll take you to pay off that loan. So we're going to set it up like this. We have a payment period, a payment, interest paid, and a principal paid. So to figure out our interest paid, we have to take our balance and we multiply it by R over N, so the rate per compounding period. So Peter is borrowing $4,000 from the bank, and at a 6% compounded monthly. So we're going to take 0.06 and divide it by 12, which is 0.005. And he's buying a ring for his fiancée, Gwen. Peter negotiated regular loan payments of $250 at the end of each month, until the loan is paid off. Set up an amortization table and determine when the loan will be paid off. So for 0 payment periods, he has a loan of $4,000. Now to figure out our interest, we take that balance and we multiply it by 0.005. So the way that we fill out this table is first we're going to say it's month 1. Our payment is $250. Now we're going to calculate our interest. So to find our interest, we're going to take 4,000 and multiply it by 0.005, and you'll get 20. So for the first month, Peter is paying $20 in interest. That means that he's going to be paying $250 minus $20, which is $230. So in a loan, you always pay the interest off first. The interest gets paid off, and then the money goes towards the balance. It doesn't go towards the balance and then the interest after. So we want to see how much of the payment is going towards paying off interest and how much of the payment is going towards the balance. So 230 is going towards the principal, which is our balance. So our last step is to go 4,000 minus 230, and you get 3,770. So that is how much is remaining on our balance. Wow. So we're going to fill out this entire amortization table. So I want you to pause the video and go to the second last box, which is going to be 16 months. So pause the video and fill it out. If you're having trouble, I'll do one more. So the next one, we're going to take 3,770 and times it by 0.005 to figure out our interest rate is $18.85. $250 minus $18.85 is $231.15. Subtract 3,770 minus 231.15, and you will get 3,538.85. So notice your interest goes down and your principal paid goes up. So pause the video, fill this out. Alright, you should get the following numbers. So for our last section here, we're at 178.71. So obviously in our next payment we are going to pay off the balance, which is going to be to 0. So we're going to take 178.71 and times it by our 0.005, and that's going to be our interest. We'll get 0.89 cents. So first we pay the interest of 89 cents, then we're going to pay the 178.71, and then our balance will be at 0. So the total payment that we made for this month was 179.6. So that was our final payment. Now we want to calculate the interest that was paid, so this is an obvious one. We just add up this column. So pause the video and add this column. You should get $179.60. And it's just a coincidence that it's that number. Don't think that that's a thing. So $179.60 is the interest paid on this loan for over 17 months, which is about a year and a half. So example 2 is a much bigger loan. So to do an amortization table for that, it would take months and months and months. So rather than making a chart that has 50 some months on it, or whatever our answer becomes to be, we're going to use the financial calculator. So you should have your financial calculator, and to use the financial calculator, it's the very same as last unit. And remember that we use this when we have a loan that we're making regular payments for. So regular, of course, means that the payments are going to be the same amount. Harry Osborne has borrowed $12,000 from a bank at 5% interest compounded monthly to buy a new hoverboard. The bank will use the hoverboard as collateral for the loan. So collateral is something that the bank uses in case you don't pay off your loan, they get to take that. So often when you buy houses, the house is held in collateral. So Harry negotiated regular loan payments of $350 at the end of each month until the loan is paid off. Using the financial calculator, determine how many months until the hovercraft is paid off. So we are going to figure out all of our values. So we have N, IY, PV, PMT, FV, PY, and CY. So our interest rate is 5. Our present value is our loan, which is $12,000. So really, this is the only thing that's different between loans and investments. For our loans, our present value is the number. We want our future value to turn into 0. He's making regular payments of $350. The payments per year are 12 because it is monthly, and it is compounded monthly. So we're going to figure out how many payments he ends up making. So we're going to type this into our calculator. So just a refresher on how to do this. We're going to first type in 5 and then IY. Then we're going to type in 12,000. So 12,000, and we'll hit present value. Then we'll hit 350 and then the plus or minus button and then payment. So 350 plus or minus payment. Then we're going to hit 12. Just kidding. We're going to hit second function IY. So this will take us to our PY. And here we're now going to push 12. And then don't forget to push enter. Then we're going to hit the up button, and we're going to hit 12 and then enter again. Then to close out of this screen, we're going to hit second function compute, and now everything is inputted, so we're going to compute our number of values. And we should get N to be 37.03. And if we take this number, our number of payments, and because there's no rounding in the calculator, without clearing the calculator screen, if we take our N value, what we've gotten on the calculator screen and we multiply it by our number of payments, this should equal how much we end up paying overall. We're also going to use the amortization table to just show how much this loan actually costs. So create a small amortization table. This is our period. This is our payment. This is our interest. This is our principal. And this is our balance. So to find our interest, we will have to take 0.05 and divide it by 12. And because this isn't an even decimal, it doesn't end, it's not a terminating decimal, we will have to multiply our balance by this every time. So first we're just going to see for 36 months, I'll tell you that the balance is $37,400. So now we're going to calculate this. We know we're at the 37th month, we're making a payment of $350. If we take $37,400 and we multiply it by 0.05 divided by 12, we should get 1.56. 350 minus 1.56 is 248.44. We subtract these two numbers, you should get 25.56, which is obviously the end of our payment, so we're going to be making a $25.56 payment on the next one, but we cannot forget the interest. So 25.56 times 0.05 over 12, and you will get 11 cents. So altogether this payment is $25.67. So that's the 38th payment. We don't end up paying all $350. So to figure out how many payments, how much this loan actually costs, we're going to take 37 times the $350 payments plus one $25.67 payment, and we ended up spending $12,975.67. We know the original loan was $12,000, so if we subtract $12,000, we get $975.67. So this is the interest that is paid on this loan. Alright, the last example. Mary Jane's employer loaned her $10,000 at a fixed interest rate of 6%, compounded annually to pay for her college tuition textbooks. The loan is to be repaid in a single payment on the maturity date. Maturity means when the loan is done, which is at the end of 5 years. How much will Mary Jane owe her employer on the maturity date, and what is the amount of interest that she had to pay? So a reason why you may choose to get a loan from someone like a person that you know, an employer, something personal, is that they might not charge you a higher interest rate, they might not charge you penalties, so it's not quite the same as taking it from a bank. They also probably wouldn't have it affect your credit score in any way. So we're going to go A, P, R, N, T. And the reason we can do just a compound interest formula for this is because we're making a single payment. And because we're waiting till the entire thing has matured and we're not making regular payments, we just use the compound interest formula. So we know our principal is $10,000. Our rate is 0.06 for 6%. It's compounded annually, so that's 1 for 5 years. So we have A is equal to 10,000, 1 plus, and because our N is 1, we don't need to write it in. So we have 0.06 to the power of 5. So 10,000 times 1.06 to the power of 5 and we should get our future value to be $13,382.26. To find our interest, we would take $13,382.26 and minus our original loan of $10,000. So she ends up paying $3,382.26. Also, her employer ends up earning $3,382.26. So that's pretty all right for him, I guess. Alright, so that's everything.